Hi friends, good morning. Today we are going to discuss Earth as a non-inertial frame, right? Because Earth is rotating about its axis. So rotating frame is non-inertial frame. In non-inertial frame, we seen, but omega is a constant, right? So we seen in previous class two kind of forces acting. One is centrifugal force, another one is Coriolis force. This is centrifugal. We studied minus m omega cross r or m omega square r perpendicular. Last class we seen. Coriolis force we studied minus 2m omega cross v dash, right? It's both we seen. Now, but this omega, suppose what is east, west, north, south representation, a body on the surface of earth. See, this is very important. Suppose a body on the surface of earth. Suppose surface is like spherical like this. So one body you consider here. One body you consider here. This is, see, body is rotating like this. So this is east, this is west, this is north, this is south. This body north, south, east, west like this only we represent, right? That is first important. Now how we represent omega in terms of in vector form, how we represent, that also very important. So now you understood this is north. See, the same figure I am using with a different color. See here, this body is at a latitude. Latitude means here equator, here pole. From equator, by what angle this body position subtended? That only latitude. Lambda is what? Latitude. If this is lambda means, again, see what is omega direction? Earth is rotating about this axis only, omega. So omega in this direction. Now this is what? This is also lambda. Then this omega you can make two component here. So this lambda means omega cos lambda j cap. See, this is j cap, this is I cap, right? This upward direction only k cap, right? Upward means from earth surface you draw one top vertical. From earth surface one vertical direction you consider, that only k cap direction. So this omega, this is j cap, this is I cap. Okay, sorry, this is the vertical direction. See, I show like this only. So this is k cap, right? This is upward, vertically upward. So see, look here, one more time I represent with a new figure I will represent. Okay, see, this is earth surface. So here one body is there. Then with the equator, this is lambda. This is j cap direction. This is your omega direction because rotating about this axis. This is upward direction. From this point, upward direction. Then this also lambda, and this is your omega. Then we have two component, omega cos lambda j cap plus omega sin lambda k cap. This is k cap direction. This is j cap direction, right? Understood? So this is then in northern hemisphere. This hemisphere we called northern hemisphere. This hemisphere we call it as southern hemisphere. Suppose you represent the same way like this. This is only omega. So this is lambda, right? So you have one vertical direction here, but this is negative. So we can write we have two components. So this only here lambda. This only here lambda, right? So we can write this as omega cos lambda j cap minus omega sine lambda k cap, right? So in northern hemisphere and southern hemisphere, how represent this vectors? Omega is equal to first omega cos lambda j cap sine lambda k cap, but in other case what? Omega cos lambda j cap minus sine lambda k cap. This representation is very important. You have to study or you have to by heart mathematically how represent omega in northern and southern hemisphere, right? All right, now we find Coriolis force acting on a freely falling board object, right? Freely falling means, see, on the earth surface, suppose one object here, it is freely falling means its velocity is downward, so minus v k cap we write. Top direction, upward direction only k cap. Then here we put 2m v cross omega, right? So 2m v dash cross omega, right? So we write cos lambda, right? Omega cos lambda, omega we can take out, omega cos lambda in northern hemisphere, what is cos lambda j cap plus sin lambda k cap cross, here one negative you put, then only you can put this negative. See, we studied Coriolis forces, right? Okay, let us continue. See, minus 2m omega cross v dash. This minus we can remove by writing v dash first, right? No issue. Now you substitute cos lambda j cap sin lambda k cap. K cross k 0, then what is remaining? K cross j. K cross j is minus I cap minus minus plus. Then 2m v dash omega cos lambda I cap. This is the Coriolis force on a freely falling object, right? So next is in southern hemisphere also same only we get it. See, 2m minus 2m omega cross v dash, I written 2m v dash cross omega, and here we written anyway k cross k equal to 0, and k cross j is minus I, minus minus cancel, here also plus I cap, right? It is in the I cap direction, there is a Coriolis force acting, right? I cap direction, one force acting means, see, very beautiful, I am drawing that figure here, see, like this only. See, one body falling here, see, which is I cap direction? I cap direction this only, this is I cap, right? This only we j cap we represented, upward direction is k cap. Now this freely falling body, there is a force in the I cap direction, means it is slowly deviate to I cap direction. That is why eastward deviation, this is actually east, that we derive later, eastward deviation of an object freely falling, that is an important physical phenomenon. Physics, it is an important thing, right? All right, now Coriolis force on river water, that also you can find. See, one river falling from north to south, so flowing from north to south. See, north to south means what we told, this is the direction j cap, then minus j cap only, what? North to south river flowing means minus j cap, then here minus v j cap, minus v j cap, minus 2m omega cross v dash only our formula, then minus 2m is there, v j cap I put, okay, minus 2m, then here, see, look here, minus 2m omega cross v dash only. So in omega you have to put as minus 2m into omega is what? Suppose here northern hemisphere, cos lambda j cap plus sin lambda k cap cross v minus v j cap, right? Minus v j cap. Now j cross j 0. Now k cross j is minus I. then minus 2m sin lambda v k cross j, what k cross j, that is minus I into minus, that is plus I, right? So negative, finally minus 2mv sin lambda I cap. So body, one river, see what is the meaning, one, this is one river flowing from north to south. It has a force in the minus I cap direction, means see the sands and all deposited this side much. Why? Because there is a force in this direction, right? All right. Now let us go to another concept. Coriolis force and centrifugal force on the sun are seen from the earth. That diagrammatically I explain. See, earth is here. Now sun is located here. By size we can write like this. Earth and sun is here. Now earth is rotating like this. It is its own axis. This is a z axis. About this axis earth is rotating, then definitely we feel one opposite velocity. Earth is rotating in this direction, means sun is stationary. From the rotating frame we feel it has in the opposite velocity, say v dash. Then v dash is equal to minus v dash I cap, right? Now centrifugal force, what a minus m into omega cross r, right? That is minus m into, what is omega? Omega is rotating about this axis only, that is k cap. Then omega k cap cross omega k cap cross this r is this vector, right? Then r j cap, r j cap, this is I cap, this is j cap, this is k cap. K cross j, what? K cross j is k cross j, that is minus I. Then here k cross direction is there, here minus I is there. K cross I, what? This is minus k cross I, that is j. Then see, Coriolis force, centrifugal force, which direction acting? It is acting in the which direction? See here, k cross I, that is in the j cap direction. K cross I, that is this minus plus k cross I j cap. So centrifugal force is always acting, suppose in this direction. Okay, centrifugal, this is j cap direction. So that only here shown. Look here, centrifugal force. Now what about Coriolis force? Coriolis force also you can minus 2m omega cross v dash. See v dash. So what I told, earth is rotating like this. Okay, Coriolis force, it is acting away. Now no, sorry, centrifugal force acting away. Now what about Coriolis force? It has a velocity in this direction as earth is rotating in this direction. Then minus 2m omega, but we cannot change it, that is k cap. About k cap only, earth is rotating here. This only earth, this only sun. Okay, so omega k cap cross v dash I cap. Am I right? All right. Now see, that is minus 2m omega cross k cross I, what? K cross I is j cap. K cross I is j cap. But here there is a problem. See, j cap only direction, that is minus j cap. That means this is j cap, this is only minus j cap, right? So it is towards, understood? So always you understand, from a rotating frame you look, Coriolis force acting, centrifugal force acting away, Coriolis force acting towards, right? All right. Now let us go to eastward deviation of a freely falling object in northern hemisphere. Okay, so we studied Coriolis force. What we studied, one object freely falling. That time it will deviate in the eastward direction, I cap direction. That we seen that Coriolis force. Now, how we can derive an expression for this? Now let us think about this. How to derive? See, first, what is Coriolis force acting on the body? Minus 2m omega cross v dash. But I written v dash cross omega and removed this sign. All right, that only we done here. That is um, minus 2m, sorry, 2m. That we see one body, suppose falling from a height. Initially x coordinate 0, y coordinate 0, and it is falling from a height h. It is falling from a height h. Suppose it is falling in the z direction, then from a height h, then z coordinate is h. Then what is the velocity of a freely falling body? Gt, right? Acceleration due to gravity minus gt k cap. Why? Because it is downward, right? So its velocity is downward. We represent minus gt k cap. So minus gt k cap 2m into minus gt k cap. That is why this negative here. Cross in northern hemisphere. What is the representation? Cos lambda, one omega you take out. Omega cos lambda j cap plus sin lambda k cap. Then 2m omega g. K cross k 0. Then 2m k cross j is minus I. Then minus minus plus. Then 2m omega g cos lambda t I cap. So definitely we understood one freely falling body. This is the direction I cap, slowly deviate into eastward direction. That means I cap direction. So it is deviating to I cap direction. What is that force? Force is equal to 2m omega g cos lambda t cap. What is that force? We can write as md square x by dt square equal to 2m omega g cos lambda t without a direction, right? Now m cancel. Integrate here. Dx by dt is equal to 2 omega g cos lambda t square by 2 plus c. But at t is equal to 0, t is equal to 0, body not started. That means there is no eastward deviation. That means x is 0. That means c is 0. So this 0 means c 0. Then what I can write? Dx by dt is equal to 2 omega g cos lambda t square by 2. 2 cancel. Now again integrate. Again you integrate means you get x. X is equal to omega g cos lambda, right? Cos lambda t square on doing t cube by 3. T cube by 3. Okay. Now this is the eastward deviation formula. But a body falling from a height h, what is the time taken to fall? T is equal to half gt square, because h is equal to initial velocity 0, so falling time is this, then t is equal to root 2h by j. If I substitute all this here, what is x value? Omega g cos lambda by 3, omega by 3 g cos lambda t cube by 3. T cube is this cube root, then 2h by g whole raised to 3 by 2. This is the eastward deviation formula. This eastward deviation formula is very important. I derived here in the same way. So see 1 by 3 omega g cos lambda to h by 3 by 2. Suppose here h you put 100 meter means you can solve 2.2 centimeter. 2.2 centimeter is the eastward deviation. That means from the earth surface a body is falling, right? It will turn 2.2 centimeter to eastward. See 2.2 centimeter in real life it is very nothing, right? So you that come to your hand only. Once you put a ball upward, then 100 meter above it go and come back, it just fall to your hand only, because 2.2 centimeter is very small. So in real life it is not experience, but kilometers of falling, there is some changes happen, right? All right. Now this all about this section. Next section we discuss with the problem from this section. Thank you.